Okay, imagine embarking on a massive construction project. Maybe a towering skyscraper.
Or a bustling hospital, yeah.
Right, or even just, your dream home. How do you make sure it doesn't spiral wildly over budget?
Or get bogged down in endless delays.
Exactly, or compromise on quality. Well, the answer often lies with a professional. You might not have heard much about them.
But who is absolutely vital.
The quantity surveyor.
It's true. These aren't the names you see splashed across architectural magazines, maybe.
Usually no.
But they are, and this is an exaggeration, they're basically the financial architects behind every single blueprint that actually comes to life.
So today, we're doing a deep dive into this, well, fascinating world of quantity surveying
Hmm.
and its critical role, sometimes kind of unseen, right, in civil engineering projects.
Absolute critical.
We're going to unpack what these experts actually do, the essential skills they need to master, and, well, how they navigate that incredibly complex financial and logistical landscape of building something.
And our insights today, they're pulled directly from some really comprehensive guides on quantity surveying, interview questions and answers.
Oh, interesting. So practical stuff.
Yeah, really practical. So you're getting a real, no-nonsense look at the core principles, the essential knowledge you'd need to grasp this field.
Okay, so our mission then in this deep dive is basically to give you a shortcut to understanding these cost whisperers of construction.
I like that term, cost whisperers.
Yeah, right. We want to reveal the surprising depth of their expertise and show why they're indispensable in bringing these ambitious visions to life.
And crucially, doing it on time and on budget.
On time, on budget. So let's peel back the layers, yeah, see what makes them tick.
Absolutely. So let's start at the beginning. What is quantity surveying? I mean, at its core.
Yeah, define it for us.
It's a specialized field within civil engineering, sure, but it's far more than just crunching numbers. It's really all about estimating, managing, and controlling construction costs,
From start to finish.
from conception right through to completion. And that also involves project planning and, this is key, risk management.
Okay.
Think of them as maybe the financial strategists. They analyze every specification, every drawing, to figure out all the required resources, the materials, and, of course, what they cost.
So it's not just counting bricks then. It sounds like there's more to it.
Oh, much more.
They're involved in managing contracts, keeping an eye on progress too. What's the sort of bigger picture of their role?
Precisely. They are continuously involved. They manage the contracts, they monitor the project's progress really closely,
Yeah.
and they give crucial advice on any potential changes to the scope maybe or the budget.
Right.
Their primary responsibility, it really boils down to managing costs, budgets, and contracts, keeping everything aligned, with the financial plan.
Okay.
And what's really interesting, I think, is how collaborative they are. They work closely with everyone.
Like who?
Well, the client, obviously, the architects, the engineers, the contractors on the ground,
Yeah.
everyone involved.
Wow.
And their ultimate goal, this is key, is making sure projects get completed on time, within budget, and to the required quality standards.
That's the trifecta.
It is.
Yeah.
And there's specific duties, things like preparing tender and contract documents, constantly assessing and managing risk, we mentioned that, and advising on the project's feasibility right from the start. Is this even viable? It's like holistic financial oversight.
Given all those responsibilities, I mean, that sounds like it takes a pretty unique type of person, a unique mind. What kind of person thrives as a quantity surveyor? What are the key skills they need?
Yeah, it's a blend you don't always find in one person, actually. You definitely need strong analytical and mathematical skills. That's sort of a given.
Sure, the numbers part.
But also really exceptional communication and interpersonal skills. Think about it. They're constantly negotiating, advising, explaining complex financial stuff to all sorts of different people.
That makes sense. You need to translate the numbers.
Exactly. And of course, attention to detail is just paramount. I mean, a misplaced decimal point, that could have huge consequences.
Yeah, massive.
On the technical side, you need proficiency in software. Things like MS Excel, AutoCAD are pretty standard. Plus, a really solid knowledge of building regulations and construction law.
Ah, the legal side.
Oh, yeah. But just as vital are the soft skills. The ability to work under pressure, meet tight deadlines. Construction is full of those. And possess strong negotiation and problem-solving skills. They're kind of part financial wizard, part diplomat.
That paints a really clear picture. Okay, so we know who they are, roughly what they do, but where do they fit into the actual timeline of a building project? Let's talk about the stages of construction and how the QS, the quantity surveyor, integrates into each one.
Right. So construction projects generally unfold in three main phases. First up, you've got the pre-construction
Well, the
stage.
planning bit.
Exactly. All the groundwork happens here. Site investigation, developing the design, getting all the permits and approvals sorted. It's the planning phase. And decisions made here can have huge cost implications later on.
Okay, stage one. Then comes the big one, the actual building.
That's right. Stage 2 is the construction stage. This is where the boots hit the ground, the actual building phase. The construction team carries out the work based on that meticulous plan and the specifications laid out.
And after the building's up,
Then you hit the post-construction stage. This covers things like testing, commissioning, making sure everything works as it should, and then the critical step, handing over the finished project to the client
and settling the final bills, I imagine.
and settling the final accounts. Precisely.
And the quantity surveyor, they're involved in all of that, from the first sketch to the final handover.
Absolutely. Woven through the whole thing. Their core role managing costs, budgets, contracts, it's integral throughout every single one of those stages.
Wow.
From conception to completion, they're there, ensuring financial prudence, making sure the contract is followed. They're like the financial thread running through the entire fabric of the project.
Okay, so if the quantity surveyor is navigating all these stages, what tools are in their kit bag? Let's start with something fundamental. Sounds like the backbone of their work, maybe? The bill of quantities, or BOQ. What exactly is that, and what's its purpose?
The BOQ. Yeah, it's foundational. It's not just a shopping list. It's the document that ensures, well, ideally, that every bid is transparent and every penny is accounted for.
Okay, so what does it list?
It's a really comprehensive document. It lists all the materials, the labor, any other resources needed for the project, and it's broken down by quantity.
Super detailed.
Very detailed. It gives you that breakdown of costs and quantities, which you then use to estimate the total cost, obviously,
Right.
but also to prepare the tender document so contractors can bid accurately.
Right.
And critically, it helps manage and control costs during the construction phase itself. It's how QS tries to prevent hidden costs and scope creep before a single shovel hits the dirt.
So it sets the baseline.
Exactly. Without a meticulously detailed BOQ, you're basically, financially speaking, building on sand.
That makes perfect sense. And tied closely to that is the idea of a cost estimate. How do they, predict the future of project spending when so much can change?
Well, a cost estimate is exactly that. It's an approximation. It's the estimated total project cost based on whatever information is available at that specific time.
Okay.
It factors in materials, labor, equipment, all those other associated expenses. But what's important to understand is that there are different types of estimates, and they evolve as the project gets clearer.
So it's not just one number.
No, not at all. You usually start with a preliminary cost estimate. Very initial, based on limited info, just a broad scope and size, maybe.
Like a ballpark figure.
Exactly, a ballpark.
Yeah.
Then, as more details emerge, you move to a conceptual cost estimate. So this one's got a more detailed understanding behind it. Specific materials, labor needs, equipment.
Getting sharper.
Right. And finally, once you have the complete plans and specifications, you get a detailed cost estimate. This is the most accurate one. It includes all the necessary costs and, importantly, contingencies for unexpected things. It's like progressively refining a financial crystal ball.
I like that analogy. Different levels of forecasting, getting more precise as you go. Okay, that leads to something I wanted to clarify. The difference between cost management and cost control. Are they the same thing, or is there a distinction?
That's a great question, actually, because they are often confused. They're related but distinct.
Okay.
Cost control is more about the process of actively managing and monitoring costs, specifically to stay within the budget.
Day-to-day tracking.
Yeah, analyzing costs in real time,
Yeah.
identifying where savings can be made if things start to drift off course. Cost management, though, is much broader. It's the overarching process.
A big picture.
Right. It covers planning, monitoring, and controlling costs from the very start of the project right to the absolute finish. So it includes developing the budget in the first place, estimating the costs, tracking all the expenses, implementing strategies to keep the overall cost within budget.
So cost control is part of cost management.
Exactly. Think of cost control as a specific tactic within the larger strategy of cost management. And the main components of cost management. They include cost planning, cost control itself, cost estimating, something called value engineering, and risk management.
Value engineering. Okay, that sounds interesting. Like the art of smart savings, finding ways to cut costs without, cutting corners. How does that work?
That's a perfect way to put it. Value engineering is all about systematically analyzing a project to find opportunities to reduce costs without sacrificing the necessary quality or functionality.
How do they do that?
Well, the process involves meticulously examining everything. the project design, the materials specified, the construction methods proposed. They're looking for smarter, maybe more efficient ways to achieve the same result, but at a lower cost.
So it's not just about making it cheaper.
No, absolutely not. It's about optimizing value, getting the most function and quality for the money spent.
That sounds incredibly useful. What are the sort of tangible benefits of doing that?
Oh, the benefits are pretty extensive, actually. Obviously, you get reduced construction costs. That's the main goal.
Sure.
But you also often see improved project performance and efficiency. It can even lead to enhanced project quality and safety, believe it or not,
Really? How so?
by finding better materials or methods
Yeah.
sometimes. And you definitely get greater satisfaction for all the stakeholders because they see their money being used wisely, being maximized.
Makes sense.
And it can even lead to reduced environmental impact through smarter material choices or construction techniques. Ultimately, it just increases the overall project value, making every dollar work harder.
Right. But of course, in any complex project, there are always risks, aren't there? Things lurking around the corner. How do quantity surveyors handle risk management? How do they anticipate and maybe mitigate challenges before they become disasters?
Risk management is absolutely fundamental to what they do. It's that proactive process, right? Identifying, assessing, and then managing potential risks, anything that could impact the project's success.
What kind of risks are we talking about?
They generally fall into several key categories. You've got technical risks, things related to design flaws maybe, or material failures.
Okay.
Then environmental risks, unpredictable weather, difficult soil conditions, that sort of thing.
Sure.
Financial risks like funding falling through or unexpected cost overruns.
The scary ones.
They can be. Legal risks too, issues with regulations or potential disputes down the line. And even political risks, policy changes that might suddenly affect the project.
Wow, it covers a lot of ground.
It does. And the quantity surveyor is constantly analyzing these potential risks and developing strategies to mitigate them, to lessen their impact throughout the whole project lifecycle. They're kind of like the project's financial risk detectives.
Okay, so pulling all of this together then, how do quantity surveyors actively manage project costs day to day? What's their methodology, their secret sauce, if you like?
Yeah, the secret sauce. Well, it's a very comprehensive, ongoing approach. It starts right at the beginning, developing that initial budget, estimating costs with as much precision as possible.
Okay.
Then they prepare all the tender and contract documents, making sure every detail is crystal clear to avoid misunderstandings later.
Sure.
Absolutely. They continually analyze and manage those project risks we just talked about. They're constantly monitoring progress, what's actually happening on site, and comparing the actual costs against the budget.
Checking for variance.
Exactly. They're instrumental in identifying those cost-saving opportunities through value engineering. And they're crucial when it comes to evaluating and negotiating any contract variations or change orders that pop up.
Right, handling the changes.
Yeah. And finally, they provide expert advice on cost and project management to all the stakeholders involved, just keeping everyone on the same financial page.
That sounds like a ton of data they're juggling. They must rely heavily on some advanced software tools for all this, surely. And what about the key financial metrics they track? Beyond just the budget, what numbers are they really watching?
You're absolutely right. Technology is a huge part of it now. They use specialized tools, things like estimating software for those initial projections, and then specific quantity surveying software to manage and control costs throughout the project.
Makes sense.
And beyond the software, they deal with some really vital financial concepts that give a true picture of a project's financial health. For instance, cash flow forecasts are essential.
What do those show?
They estimate the inflows and outflows of cash over time. It's crucial to make sure the project always has enough liquidity, enough cash on hand to pay bills when they're due.
Got it.
They also understand concepts like depreciation, which is the reduction in an asset's value over time, important for the long-term view.
Okay.
And they use quite sophisticated metrics like internal rate of return, IRR, and net present value, NPV. These really help evaluate a project's long-term profitability and financial feasibility. Is this project actually a good investment?
Right, the bigger financial picture.
Exactly. And they often perform life cycle cost analysis. This looks at the total cost of owning and operating an asset over its entire lifespan, not just the initial construction cost, but maintenance, energy use, eventual disposal. It's about predicting the financial journey from day one to decades down the road.
Wow, that's some serious financial and analytical heavy lifting. But construction, as we know, isn't just about numbers. It's also about legal agreements, managing changes when they happen. Let's shift gears a bit and move into the legal landscape, starting with a fundamental distinction. What's the difference between a tender and a contract?
Right, good distinction. A tender is basically a formal invitation. It's usually sent out to contractors asking them to submit a detailed proposal or bid to carry out a specific construction project.
So it's the offer stage?
It's the offer stage, yeah. It includes all the necessary specifications, drawings, everything they need to prepare their bid accurately. A contract, on the other hand, that's the legally binding agreement that's formed after a tender is accepted.
Okay, the deal is done.
The deal is done. It outlines all the terms and conditions, the project specs, the scope, budget, schedule, everything agreed between the client and the chosen contractor. So yeah, the tender is the proposal, the contract is the legally binding promise.
Got it. And once that contract is signed, what happens when things inevitably change? Because let's face it, they almost always do, right? How do they manage variations, or what some people might call change orders or change directives?
Changes are indeed reality in construction, almost guaranteed. A variation is simply any alteration to what was originally agreed in the contract, a change to the scope, the requirements, the schedule, maybe the budget.
Okay.
How are they managed? Well, it's all about following the procedures that are actually outlined in the contract. It's about due process.
Sticking to the rules.
Absolutely. This usually involves assessing the precise impact of the change, how does it affect the scope, the schedule, the cost, and crucially, getting formal client approval before going ahead with the changed work. It's a structured process to avoid surprises or disputes later.
Makes sense.
And then at the very end of the project, all these agreed variations are meticulously compiled into what's called the final account.
Ah, the final tally.
Exactly. It summarizes the total final cost of the project, including all those adjustments and variations ready for the final payment.
It sounds like there are quite a few ways clients protect themselves financially in these contracts, too. What about bonds? I sometimes hear about performance bonds or payment bonds. What are those, and what do they protect against?
Yes, bonds are really critical forms of financial security in construction contracts. A performance bond is essentially a guarantee from a third party, usually an insurance company, that the contractor will complete the project according to the contract terms.
And if they don't?
If they fail to perform, the client can make a claim on the bond to cover the costs of finishing the project or fixing defects.
Right, that's significant protection. What about payment bonds?
A payment bond guarantees that the contractor will pay their subcontractors and suppliers for the work and materials they provide. This protects the client from having liens placed on their property if the contractor doesn't pay their bills.
Also very important. And bid bonds.
A bid bond is often required during the bidding process itself. It basically guarantees that if a contractor submits the winning bid, they will actually sign the contract and provide the required performance and payment bonds. It stops bidders from backing out after winning.
So these are all about mitigating financial risk for the client, right? And ensuring the project keeps moving forward.
Exactly. They provide a safety net and encourage contractors to fulfill their obligations.
And what are some of the other key contractual clauses designed for protection? Those specific bits of text in the contract that can really save a project if things go wrong?
Yeah, there are several common ones that are incredibly important. An escalation clause, for example. This allows for adjustments to the contract price if there are unforeseen, significant increases in the cost of labor or materials. Protects both parties, really, from volatile markets.
Okay, useful in uncertain times.
Very. Then there's a liquidated damages clause. This stipulates a pre-agreed amount of money that the contractor has to pay the client for each day they are late in completing the project beyond the agreed date. It provides clear financial consequences for delays caused by the contractor.
So an incentive to finish on time?
Precisely. The force majeure clause is also crucial. This excuses a party, either the client or the contractor, from fulfilling their contractual obligations due to unforeseeable circumstances completely beyond their control.
Like what? Natural disasters.
Exactly. Natural disasters, pandemics, acts of war, things like that. Events that make performance impossible or impractical.
Got it. And what about retention or retainage?
Right. Retention or retainage is a percentage of the value of the work done, usually maybe 5 or 10%, that the client holds back from payments to the contractor. As security, yes. It's typically released in stages, maybe half upon practical completion of the project, and the final half after a defects liability period once any identified defects have been fixed by the contractor. It's a final safeguard to ensure quality and completion.
Okay. So even with all these safeguards, disputes can still happen. What occurs then? What's the quantity surveyor's role in dispute resolution, and what methods are typically used to resolve conflicts?
Yeah, disputes are unfortunately not uncommon in complex projects. Dispute resolution is simply the process used to resolve these conflicts when they arise.
And the QS's role.
The quantity surveyor is often deeply involved, especially if the dispute relates to costs, payments, or variations. They provide the detailed financial data, measurements, and contractual analysis needed to support a claim or defend against one.
So they provide the evidence?
Often, yes. As for the methods used, there's usually a hierarchy, moving from informal to more formal processes. You typically start with negotiation, just informal discussion between the parties trying to reach an agreement themselves.
Okay, try talking first.
Always the best first step. If that fails, you might move to mediation. This involves bringing in a neutral third party,
Okay.
a mediator, who facilitates the discussion and helps the parties find common ground and reach their own settlement. The mediator doesn't impose a decision.
Right, helps them talk.
Exactly. If mediation doesn't work or isn't appropriate, you might go to arbitration. This is more formal. An arbitrator, or a panel of arbitrators, acts like a private judge. They hear evidence from both sides and then make a decision that is usually legally binding.
So a binding decision outside of court.
Correct. And finally, the last resort is usually litigation, which means taking the dispute to court and having a judge decide the outcome. This is typically the most time-consuming and expensive option.
Got it. Now, one more thing on contracts that seems really important. Who actually manages the cost depending on the type of contract? That sounds like a pretty significant difference for the client, right?
Right. Oh, it absolutely is. It fundamentally shifts where the financial risk lies. Let's look at the main types. With a lump sum contract, the contractor agrees to do the entire project for a fixed, pre-agreed price. In this case, the contractor bears most of the risk of cost overruns. They have to manage their costs very carefully to stay within that fixed sum and make a profit.
So the client knows the price up front.
Largely, yes, barring any agreed variations. Then you have cost-plus contracts, sometimes called cost-reimbursable contracts. Here, the contractor is reimbursed for their actual, allowable costs incurred in doing the work, plus an additional agreed fee or percentage for their overhead and profit.
So the client pays whatever it costs plus profit.
Essentially, yes. So in this model, the client bears most of the cost risk. If costs go up, the client pays more. They, or a QS, usually need to monitor costs very closely.
Right, more oversight needed.
Definitely. And finally, there are unit price contracts. In this type, the contract is based on estimated quantities of specific items of work and pre-agreed prices per unit for those items like dollars per cubic meter of concrete poured or per square meter of wall built.
So you pay based on how much is actually done.
Exactly. The contractor is paid based on the actual measured quantities of work performed, multiplied by those agreed unit prices. The contractor manages their efficiency to make those unit prices work, but the final cost depends on the actual quantities, which the client, through their QS, will verify. So the risk is shared somewhat.
That makes the differences really clear. Okay, this has been an incredible tour of the quantity surveyor's world. Let's maybe step beyond the basics now for a bit, look at some crucial distinctions, maybe some modern concepts shaping the industry, and then maybe dive into some of those fascinating technical details that, well, that make this field really tick.
Sounds good.
First, a distinction that sometimes comes up. Quantity surveyor versus valuer, they sound kind of similar, deal with property and cost. Are they the same role?
That's a common point of confusion, but they are distinct roles, though they both operate within the construction and property sectors.
Okay, how do they differ?
Basically, quantity surveyors, as we've discussed extensively, focus on the cost and management of construction projects, the process of building them right and on budget. Valuers, on the other hand, sometimes called appraisers, are concerned with estimating the market value of existing properties and assets.
Ah, existing property value.
Exactly. A valuer would produce a valuation report. They use specific methods like the sales comparison approach, what similar property sold for, the cost approach, what it would cost to rebuild, or the income approach based on rental income to determine a property's current market worth.
So QS manages the cost to create something new. Valuer assesses the market value of something already existing.
That's a great summary. One looks forward during construction, the other looks at the present market value.
Got it. That's clear. Now, what about modern construction concepts? What kinds of projects or approaches are changing the landscape of how we build today?
Yeah, the industry is definitely evolving. We're seeing a significant rise in green buildings, for example. These are buildings designed specifically to be environmentally sustainable, energy efficient, resource efficient throughout their entire life cycle.
Sustainability is huge now.
Absolutely. There are also design build projects. This is a delivery method where a single entity, One company or a joint venture holds the contract for both the design and the construction of the project.
Streamlining things.
Exactly. You can streamline the process, potentially speed things up, and provide a single point of responsibility.
Yeah, what else?
Public-private partnerships, PPPs, are becoming more common, especially for large infrastructure projects. These are long-term contractual agreements between a public agency, like a government department, and a private sector entity.
For building roads or hospitals, maybe?
Precisely. The private entity finances, builds, and often operates the facility, taking on significant financial and operational risks in return for payments from the public sector over the life of the contract.
Interesting model.
It is. We also often distinguish between greenfield projects and brownfield projects. Greenfield means building on previously undeveloped land, like a field.
Starting fresh.
Right. Brownfield projects involve building on land that has been previously developed. This often comes with complexities like needing to demolish existing structures or, very importantly, dealing with potential contamination from previous industrial use environmental remediation.
So, more challenges there.
Often, yes. And finally, another concept gaining traction is lean construction. This applies principles originally developed in lean manufacturing, like from Toyota to the construction process.
How does that work in building?
It focuses intensely on reducing wasted time, materials, effort, improving workflow efficiency, and maximizing value for the client throughout the construction process. It's all about building smarter, not just bigger or faster necessarily.
Fascinating. Okay, here's where it gets really interesting for me personally. Getting into some of those specific, technical details that, as the expert, you probably live and breathe. When you're putting together a detailed cost estimate, what kind of raw data do you absolutely need to make sure it's accurate down to the last, nut and bolt?
Yes, the real nuts and bolts. Okay, for a robust, reliable building estimate, a quantity surveyor needs several key pieces of information. First, the detailed project specifications. These describe the quantity, the type, the quality, the installation method, the size, everything, for every single piece of work.
The instruction manual.
Pretty much, yeah. Then you need comprehensive architectural and engineering drawings, both 2D plans and increasingly 3D models that map out the entire structure in detail.
The blueprints.
The blueprints, exactly. And critically, you need very precise, location-specific material and labor rates. The cost of concrete, bricks, labor, equipment hire varies hugely depending on where the project is. A QS needs to know exactly what the local market dictates at that time. This data forms the bedrock of any accurate estimate.
Makes sense. Local knowledge is key. And what about some of their specific duties on a project? Those daily or weekly tasks that really show how deeply involved they are financially.
Yeah, beyond the big picture roles we talked about, they get into some very granular tasks. For example, preparing detailed cash flow statements not just for the overall project, but for all project activities. This includes tracking things like bank guarantees, margin money held, service taxes, specific office costs, direct site costs, material costs as they're incurred.
Really detailed tracking.
Very detailed. They prepare the interim payment applications or client bills for the work that's been completed, usually monthly. And they meticulously verify and certify the payment claims coming in from subcontractors and suppliers, checking the work done against the contract.
Checking other people's bills.
Precisely. A really critical ongoing task is material reconciliation. This means tracking the amount of material delivered to site versus the amount actually used in the works, according to the drawings and specs. It helps identify and control wastage.
Seeing if materials are going missing or being wasted.
Exactly. And they perform detailed rate analysis. This is where they break down the cost of individual work items, like 1 cubic meter of concrete, into its components. Materials, labor, plant, overheads, profit. This helps build up estimates, price variations, and assess subcontractor quotes. It's truly comprehensive financial management at a micro level.
Wow. Okay. What are the core contractual documents they're dealing with constantly, the essential paperwork that defines the project day to day?
The absolute essential contractual documents usually include the detailed design drawings, architectural, structural, mechanical, electrical, etc., the precise specifications detailing the quality of materials and workmanship required. Comprehensive work information or schedules of work, critical site information that details things like ground conditions, access routes, existing services, and the all-important program of works, which is the project schedule or timeline. These documents collectively form the legal and practical roadmap for the entire build.
Got it. Let's get really specific now for a moment into the materials side. When we talk about aggregates for concrete, the sand and gravel, what's the technical size range that distinguishes fine aggregate from coarse aggregate? Is it just, big bits and small bits?
Yeah, essentially, yes, but there are precise technical definitions based on sieve sizes,
Hmm.
which are critical for getting the concrete mix right. Fine aggregate is generally defined as a material that passes through a 4.75 millimeter sieve. Think of it like sand or very fine crushed stone.
Okay, small stuff.
Right. Coarse aggregate is the material that is retained on that same 4.75 millimeter sieve, so it's the larger stuff gravel, larger crushed stone.
And why does that exact size matter so much to a QF?
Well, the proportions and sizes of fine and coarse aggregate profoundly affect the properties of the concrete. Its workability when wet, its strength when hardened, its durability over time, and also its cost, because aggregates make up the bulk of concrete. Getting the mix wrong based on incorrect sizing can lead to structural problems or wasted materials. So the QS needs to ensure the right stuff is specified, ordered, and paid for.
Okay, precision matters. Now, what about bulking? What does that mean in this context? Sounds a bit strange.
Chuckle slightly. Yeah, it does sound a bit odd. In construction, bulking specifically refers to the increase in the volume of fine aggregate, particularly sand, when it contains a certain amount of moisture.
So, wet sand takes up more space.
Exactly. Even a small percentage of moisture, typically around 4 or 6%, causes the fine sand particles to be pushed apart by surface tension, making the sand bulk up and occupy a larger volume than it would if it were completely dry or fully saturated.
Why is that important for a QS to know?
It's critical for measurement and batching. If you measure sand by volume when it's bulked, you'll actually get less solid sand material than you think you're getting. If you don't account for this bulking effect when mixing concrete, your mix could end up with insufficient fine aggregate, which affects its properties, strength, and finish. So QSs need to be aware of it for accurate quantity calculations and cost control.
Right. You could end up ordering or paying for air and water. Okay, moving to cement. Which type of cement is typically preferred for general building construction where you want the strength to continue developing over a long period, increasing with age?
For that characteristic long-term strength gain, the cement often favored in general building construction is PPC, which stands for Portland Pozzolana Cement.
PPC. Why that one?
While ordinary Portland cement, OPC, gains strength faster initially, PPC contains pozzolanic materials like fly ash, which react with byproducts of the cement hydration over a longer period. This leads to a denser, less permeable concrete that continues to gain strength gradually over months and even years, enhancing long-term durability.
Interesting trade-off. Okay, here's a number question. What's the standard accepted unit weight of reinforced cement concrete, or RCC? I imagine knowing that weight is vital for structural calculations.
It absolutely is. It's a fundamental figure used in calculating loads on structural elements and foundations. The generally accepted standard unit weight of normally compacted reinforced cement concrete, RCC, is 25 kilonewtons per cubic meter. 25 kilonewtons.
25 kilonewton, got it.
Sometimes you might see 2,500 kilonewton used as well, which is roughly equivalent. It accounts for the concrete itself plus the typical amount of steel reinforcement within it.
Makes sense. And what about a damp-proof course, or DPC? What's a common thickness for that? And remind us quickly what it's for.
A damp-proof course, the DPC, is that barrier built into walls, usually just above ground level, to prevent moisture from the ground rising up into the building through capillary action, what we call rising damp.
Right, stops the damp coming up the walls.
Exactly. And a very common standard thickness specified for a DPC layer, whether it's a bituminous material or a plastic sheet, is 50 millimeters, or 2 inches.
50 mil. Okay, now, water quality for concrete. You mentioned pH earlier. What's the recommended pH range for water used in mixing concrete? Does it really make a difference?
So it absolutely makes a difference. Water quality can significantly impact how the cement hydrates, which affects the final strength and durability of the concrete. Water that's too acidic or too alkaline can interfere with those chemical reactions.
So what's the safe zone?
The generally recommended pH value for water used in concrete mixing should fall between 6.0 and 8.5. Outside of this range, especially if it's significantly acidic or contains harmful salts or contaminants, it can lead to weaker concrete or even corrosion of the reinforcement steel over time.
Good to know. Okay, shifting to steel reinforcement now. What is BBS? I hear that acronym sometimes.
BBS stands for Bar Bending Schedule. Think of it as the definitive instruction manual for all the steel reinforcement bars, rebars that go into a concrete structure.
The instructions for the steel guys.
Precisely. It's a detailed list, usually presented in tables, that itemizes every single type of bar used in a specific structural element, like a beam, column, or slab. It specifies the bar's shape, diameter, length, bending dimensions, quantity, and location.
Why is it so important?
It's absolutely crucial for accuracy. It allows the steel fixers on site to cut and bend the bars exactly as the structural engineer designed them. It also allows the quantity surveyor to accurately calculate the total quantity of steel required for ordering, costing, and payment verification. It avoids errors and minimizes waste.
Makes sense. And what about a material statement? What does that show?
A material statement is essentially a calculation sheet or table that shows the quantities of the basic constituent materials needed to produce a specific unit of a finished work item.
Can you give an example?
Sure. For, say, 1 cubic meter of a particular grade of concrete, the material statement would list the required quantities of cement in bags or kg, fine aggregate, sand in cubic meters or tons, coarse aggregate, gravel in cubic meters or tons, and water in liters. Similarly, for 1 square meter of brickwork, it would show the number of bricks and the volume of mortar, which itself breaks down into cement and sand.
So it helps figure out raw material needs from the finished work quantities.
Exactly. It's a key tool for estimating material requirements for the whole project based on the quantities measured in the bill of quantities.
Okay, and one last technical term for this section, analysis of rates. What's that process?
Analysis of rates is fundamental to cost estimating and pricing construction. It's the detailed process a quantity surveyor uses to determine the cost of carrying out 1 unit of a specific work item, like 1 cubic meter of excavation or 1 square meter of plastering.
How do they figure that out?
They break down the work item into all its cost components. This includes the cost of the materials needed, using those material statement quantities and current rates, the cost of the labor required, how many hours of different tradesmen multiplied by their wage rates, the cost of any plant or equipment needed, like hiring an excavator, plus allowances for overheads, site supervision, office costs, etc., and the contractor's profit margin.
So building up the price from the ground up.
Exactly. By analyzing all these components, they arrive at a total cost per unit for that item of work. This rate is then used to price the quantities in the bill of quantities to build up the total project estimate or tender price. It's a really detailed and crucial calculation.
These details really do highlight the incredible precision and depth required in this field. It's fascinating stuff. Now, looking ahead, let's talk about the future. What's the future hold for quantity surveying and valuation in civil engineering? It can't all be clipboards and Excel spreadsheets forever, can it?
You're right, the field is definitely evolving, and quite rapidly, actually. It's an exciting time. The future is likely going to be shaped significantly by emerging technologies. Things like artificial intelligence, AI, machine learning, ML, and automation are poised to make a big impact.
How so? Will they replace the QS?
I don't think they'll replace the QS, not entirely. The judgment, negotiation, and strategic thinking aspects are hard to automate. But these technologies will likely augment the QS's capabilities. They'll enable much more accurate and efficient cost estimation, perhaps analyzing vast amounts of historical data. They'll help with scheduling, risk analysis, and overall project management, likely improving the construction industry's notorious inefficiency and boosting sustainability.
So making them more effective, less bogged down in repetitive tasks.
Exactly, freeing them up for higher-level strategic advice. Additionally, that increasing global focus we mentioned on sustainability and green construction practices, that's huge. It will undoubtedly create significant new opportunities for quantity surveyors and valuers who develop expertise in these areas, understanding green building certifications, life cycle costing of sustainable materials, carbon accounting in construction.
So specialization in green building will be key.
Very likely. Their role will probably become even more strategic, advising on value and sustainability, and less purely focused on manual measurement and calculation, as software takes over more of that.
Okay, so wrapping this all up then, what does this all mean for you listening? We've taken quite a deep dive into quantity surveying today.
We certainly have.
And hopefully revealed it as this really sophisticated blend of engineering knowledge, economic principles, and even legal understanding.
Yeah, it's a real mix of skills.
These professionals, they're kind of the unseen architects of project viability, aren't they? Ensuring that these ambitious visions we have can actually be built within the constraints of the real world time and money.
They really are. You could say they're the financial backbone supporting every blueprint, making
Yeah.
sure every dollar spent or pound or euro actually builds towards the intended goal.
It's a field that clearly demands both that rigorous analytical skill we talked about, but also that keen foresight, that ability to see potential problems before they happen.
Absolutely. They truly bridge that often wide gap between the design aspiration, the dream, and the financial and practical reality of getting it built, turning concepts into concrete achievements, quite literally.
And here's maybe a final thought for you to mull over as we finish. The core principles of quantity surveying, that meticulous planning, the rigorous risk assessment, the continuous cost control, the strategic adaptation to change these, aren't just for building skyscrapers or hospitals.
That's a great point.
They feel like universal tools, right, for managing any complex endeavor, whether you're maybe overseeing a business initiative, planning a major event, or even just working towards your own big personal goals. How might thinking a bit more like a quantity surveyor, being that cost whisperer for your own projects, change how you approach whatever your next big undertaking might be?
Something to think about, definitely. Applying that discipline to other areas of life.